Welcome back to your Ultimate Data Science course, and I'm super excited about today. I've got an incredible tutorial prepared for you. We're going to cover off a very important topic, and that is how to build models step by step. I couldn't hold myself. I had to add that extra line step by step to the name of the tutorial because that is exactly what we're going to be looking at. I'm going to give you a framework for several different methods, and it's all going to be step by step. So let's jump straight into it. Do you remember the good old days when we had one dependent variable and one independent variable? Everything was easy and we just had a simple linear regression that we had to build and everything worked great. But now, in our data, we have all these columns. Those easy days are gone. Now, all of these columns are potential predictors for our dependent variable, and there's just so many of them. And we need to decide which ones we want to keep and which ones we want to throw out. And you'll ask, why do we need to throw out columns? Why do we need to get rid of data? Why can't we just use everything in our model? Well, I can think of two reasons off the top of my head. Number one is garbage in, garbage out. If you throw in a lot of stuff into your model, then your model will not be a good model. It won't be reliable, it won't be doing what it's supposed to be doing. It's going to be a, so to speak, garbage model. And number two, at the end of the day, you're going to have to explain these variables and understand not just the math behind them, but actually what it means that certain variables predict the behavior of your dependent variable. And you will have to explain that to your executives, to your boss, to people you're presenting to. So if you have 1,000 variables, it's not going to be practical to try and explain that. So you want to keep only the very important ones, the ones that actually predict something. So how do we construct a model? This is the process of building the model, selecting the right variables. So how do we construct a model? Well, there are 5 methods that we're going to discuss of building models. Number 1 is all-in. Number 2 is backward elimination. Number 3 is forward selection. Number 4 is bidirectional elimination. And number 5 is score comparison. We're going to talk about each one of them just now. Before we do, I wanted to say that sometimes you'll hear stepwise regression. So stepwise regression actually refers to number 2, 3, and 4 because those are like really the true step-by-step methods. But sometimes you will hear people say stepwise regression in reference to just number 4. So they will replace bidirectional elimination with stepwise regression, and that's fine. That's normal. That's just because that's the more, as you'll see from what we discussed, bidirectional elimination is kind of the more general approach. And when people say stepwise regression, they kind of by default imply that it's bidirectional elimination, and you have to infer it from there. Okay, so let's move on to our methods. Method number 1, all in. It's not a technical term. I just call it all in. Basically, what it means is just throw in all your variables, something we just discussed that we shouldn't do. When would you do that? One is if you have prior knowledge. If you know that these exact variables are your true predictors, you don't have to build anything. You already know that this is the case. You might know it from domain knowledge, or you might know it because you've done this model before, or somebody just gave you these variables and said, please build a model. Well, then you don't really have a choice. You just build the model. The other one is you have to. Perhaps, like, I can't really think of good examples here, but maybe there's some framework in your company that says that you have to use these variables, right? So it's kind of similar to prior knowledge, but it's not your decision. You might want to do it differently, but there is a framework, like maybe a bank, and to predict credit, like or the likelihood of somebody defaulting on something, they have to use these specific variables. Once again, I'm not sure in which industries that would be the case, but perhaps that could be the case. And number 3, you would use this method if you're preparing for a backward elimination type of construction of regression, which is our next type. So let's move on to backward elimination. Okay, so here comes the step-by-step stuff. You might want to get your pens out and write these things down because we're going to have a truly step-by-step method now. All right, backward elimination. first thing, step one, you have to select a significance level to stay in the model. So by default, we're going to go with 5%, so 0.05, and we're going to use it in the next step. So at the beginning, you decide on this significance level. Step two, you fit the full model with all possible predictors. So you kind of do that all-in approach, which we just talked about, and you put all of your variables into your model. And now we're going to start getting rid of them. Step three, you consider the predictor with the highest p-value. So remember those p-values that we talked about in, for instance, in Gradle or in any software, you can see them. So after you fitted the model, you'll see the one with the highest p-value. So if p is greater than your significance level, then you go to step four. And step four is you have to remove that predictor. So you remove basically the variable that has the highest p-value. And from step four, you fit the model without this variable. So there's a star here because I just wanted to remind myself to tell you that if you just remove the variable, obviously you can't just say that, okay, now I've got the new model. You have to actually refit the model. You have to recreate the model, rebuild it with the fewer number of variables. So if you had maybe, I don't know, 100 variables and you removed them, one of them, you have 99 now, well, you have to rebuild it. So the coefficients are going to be different. The constant is going to be different. And you need to perform that step because once you remove a variable, it affects all the other variables in your whole regression. And so after step five, you go back to step three. Once again, you look for the variable with the highest p-value in your new model. You take it out, you remove, so basically step four, you remove it, you fit the model again with one less variable and so on. You keep doing that until you come to a point where though even the variable with the highest p-value, that p-value is still less than your significance level. So if that condition p is greater than SL is not correct, then you don't go to step four anymore. You go to fin. In this case, fin is the finish. Your model is ready. So as soon as all of the variables that you have left in your model their p-values are less than the significance level, your model is prepared. So that's how the backward elimination method works. Let's move on to the next one. Next method is the forward selection. It sounds like the opposite, and the picture in the top right corner does illustrate the opposite, but it's much more complex than just simply reversing the procedure. You will see that it's a much larger procedure. We start with step one. Select the significance level to enter the model. And in this case, once again, we're going to select 5%. Then we go to step two. We fit all possible simple regression models. So we take the dependent variable and we create a regression model with every single independent variable that we have. And then we select, out of all of those models, we select the one which has the lowest p-value for the independent variable. So you can already see that that is in itself a lot of work. Then what we do is we move to step three. We keep this variable that we've just chosen, and we fit all other possible models with one extra predictor added to the one you already have. So what does that mean? That means we've selected a simple linear regression with one variable. Now we need to construct all possible linear regressions with two variables, where one of those two variables is the one we've already selected. So basically we add on all of the other variables one by one. So we choose, okay, let's add on this variable, and then let's add on the next one, but separately. So we construct all possible two variable linear regressions and just definitely keeping the variable that we've already selected. So what do we do after that? Out of all of these possible two variable regressions, we consider the one where the new variable that we added had the lowest p-value. So if that p-value is less than our significance level, meaning that that variable is a good one, it's a significant variable, then we move back to step three. What does that mean? It means that now we have a regression with two variables, and now we will add a third variable, and we'll try all possible variables that we have left as our third variable. And then out of all of those models with 3 variables, we will go to step 4 and we'll select again the one with the lowest p-value for that 3rd variable that we added. And we'll keep doing that. So basically we'll keep growing the regression model, but not just randomly. We'll be actually selecting out of the all of the possible combinations every single time and growing it with 1 variable at a time. And then we will only stop when the variable that we've added, it has a p-value that is greater than our significance level. So when this condition p is less than SL is not true, then we don't go to step 3, we finish the regression. Why? Well, because that variable that we just added is no longer, is not significant anymore. And we also know that we selected the one with the lowest p-value. So there's no other variable that we can add that its p-value will be greater or will be less than SL. Any regression that we choose from then onwards, it will, the new variable will always be insignificant. And so here we finish the regression, and the trick here is that you keep not the current model but the previous one. And that makes sense because you've just added a variable which is insignificant. So what's the point of that variable? Just move a step back. So that's how forward selection works. I know it's a bit confusing, but just try to wrap your head around it. Maybe read through these instructions one more time. It does make a lot of sense when you kind of picture what exactly is going on. And next, we're moving on to the bidirectional elimination. So this one, as you can assume or perhaps guess, it combines the two. Step 1, select a significance level to enter and a significance level to stay. So we're going to select in both cases 5%, but it's up to you what you select. Step 2, perform the next step of the forward selection, meaning that the one that we just discussed, so where new variables, when they enter, in order to enter, they have to be less than the significance level to enter. So basically add on a new variable based on the forward selection method. Step 3, perform all of the steps of the backward elimination process. So now, if you have 2 variables, start getting rid of them and see if you can get rid of any of them. And then move back to step 2. So then grow it by another variable. And every time you grow it by a variable, say, let's say you were at 5 variables and you went to 6. As soon as you went to 6, you have to perform all of the steps of backward elimination. So you don't just eliminate one variable if you can. You eliminate 1, 2, 3, however many you can. And then from there, you go back to step 2. And so this is a very iterative process. You keep doing that until at some point you cannot add new variables, no variables can enter, or no old variables can exit. And as soon as you get there, then you proceed to the finish because your model is ready. You can't add anything, you can't take anything out. That means you've created the model. So this is one of the more tedious methods. Of course, you would have to get a computer to do this for you because otherwise you'd go insane putting variables in and taking them out. But that's how bidirectional elimination works. Once again, some people call it stepwise regression. And finally, all possible models. So this is the most probably thorough approach, but also the most resource consuming approach, because you select a criterion of goodness of fit. For instance, the Kaiki criterion can be the R squared, lots of different criterions. Then you construct all possible regression models. So if you had n variables, then there'll be a 2 to the power of n minus 1 total combinations of these variables, and that's exactly how many models there can possibly be. And then step 3, you select the one of these models with the best criterion that you're looking at. There you go, your model is ready. So sounds easy, but let's have a look at an example. Even if you have 10 columns in your data, you'll have 1,023 models. That's insane. That's an insane amount of models. And we're not talking about columns that you've already filtered out. So columns that that's like in our example, you might have 5 or 6 columns. No, we're talking about when you get a data set that you just is pretty much raw and it has like maybe 100 columns. Like I've worked with data sets with around that, maybe 50 to 100, maybe more columns. And instead of going through them, what this method is suggesting, instead of going through them and picking out the ones that you think should be in your model, you just throw everything in. Well, it's not a good approach because basically it's growing exponentially. The number of models is growing exponentially, and it's very, resource consuming to get a result from this approach. And finally, so where have we come to? We've come to our conclusion. We have 5 methods of building models. All in, backward elimination, forward selection, bidirectional elimination, and score comparison. So the one we're going to be looking at in these tutorials in order to get our head around how to build models step by step and get some practice is the backward elimination process, because it is the fastest one out of all of them. And you will still get to see exactly how the step-by-step method works. And plus, we'll throw in a few extra tricks along the way to make sure our models are very robust. Can't wait to get started. Lots of theory. Let's get to the practice. I look forward to seeing you next time.